Hey there, ladies and gentlemen. Welcome to, what is this, lesson 5.4? Yeah, it's 5.4. This is the first part of 5.4. We're talking about compound inequalities. We are going to split this into two different types of lessons. This one's going to be called the intersections, and we'll describe that for you in just a little second here. So an intersection is when you have a graph of compound inequalities, and that graph has a part where they overlap, and that's why it's called an intersection. So what we're going to do is we're going to notice that the two lines are going to overlap each other, and that's going to be the spot where the inequality is going to be true, is where those things overlap. The word "and" is what you're going to hear me using the most, because these are "and" types of compound inequalities. Our next lesson will be called unions, and they will be "or" types of inequalities, but this one's called "ands." So the biggest idea here, now obviously since you guys are not able to do this right now, you can't think it, pair it, and share it, I'll just tell you how this works out. So how would you say the following inequalities? What you're going to do is you're going to look at the part in the middle where the x minus 3, where our variable is, and you're going to read this inequality from the perspective of where the x is. So you're going to say x minus 3 is greater than or equal to a negative 2. And then the other way you could look at it, in blue I'll underline this one, I think it's blue, is you'll read it from this part. So it's like covering up that part of the problem. And it'll say x minus 3 is less than 4. So we have two different problems that we're really solving, but we're putting them together in one specific problem. And this is an intersection, an "and." All right, so here's our first compound inequality. They're not horribly complicated, but they are somewhat complicated. I'm going to keep it really, really simple for you. The easiest thing to do is I can take the stuff in the middle and I can work from undoing what's happening to our variable. So I'm going to take this n plus 2 and go minus 2 in the middle. If I go minus 2 in the middle, I also need to do minus 2 on the outsides. So if you imagine it as having three parts of the problem, the left, the middle, and the right, you'd be able to simplify this process a little bit. So when I do that math, I'm now left with a 7 minus 2, which is 5. I have that in the middle, it cancels because a positive 2 and a negative 2 makes 0. And then 11 minus 2 is 9. I'm left with the n in the middle, and then my signs that I've kind of covered up with the line, those signs are going to transfer down our line because we didn't multiply or divide anything by a negative. We just subtracted things. So it's going to keep the same sign that I had before. So this would be an answer of n is greater than 5 and n is less than 9. So if I were to graph that on a number line, I have, let's go 4, 5, 6, 7, 8, 9, 10. So because of my symbols here, I'm going to have an open circle at 5, and n is greater than, so it's going to be going this direction. I have an open circle at 9, and since n is less than 9, it's going this direction. You will notice that my overlapping part is right here. So what I really want to have is this piece right here. So my number could be between the number 5 and 9 to make this compound inequality true. It can't be 5, it can't be 9, but it's numbers as close to 5 as possible that are bigger than it, and as close to 9 as possible that are smaller than it. So those are the solutions that work for this compound inequality. Now, those are ands because they intersect. All right, so here's another one. Now this one says the word "and" in it. So we can think of it as two separate problems like are written down. Y minus 3 is greater than or equal to a negative 11. Y minus 3 is less than or equal to negative 8. We can solve them separately, just like we kind of did on the last one, or we can combine them into a compound inequality and make it happen all at once. We'll do it separately this time. So I'm going to do a plus 3 to both sides to get the y by itself. And I'm going to do that for both equations or inequalities right away. And I'm left with y is greater than or equal to a negative 8. And on the second one, y is less than or equal to a negative 5. So my number line goes from a negative 9, negative 8, negative 7, negative 6, negative 5, negative 4. I'm going to have closed circles at negative 8, closed circle, a closed circle at negative 5. Now y is greater than or equal to negative 8, so that's going to the right. Y is less than or equal to negative 5, so that's going to the left. So my intersection of these two things is happening right here. And that's why it's an and. All right, let's give you one more. Oh, that's all of it? All right, folks. As you can imagine, if there were to be a scenario, I want to give you one idea here, where we have an and, we're looking for things to intersect, and this one goes that way and this one goes that way, which means that they never, never, never intersect. This would be a no solution type of problem. So if they're supposed to intersect but they never do, that's a no solution. All right, folks, we're keeping it simple here in the Berman Nation, but I'm signing off. This is 5-4, the intersection.